Today we're going to continue talking about area. We're going to talk about area as it pertains to circles and sectors. So we know that the formula for the area of a circle, or at least I hope we know, is area. Let me get my pen here. Area is equal to pi times the radius squared. Okay. This is kind of a little visual proof of why that would work. If you cut the circle into a whole bunch of little tiny wedges and then you arrange them like this as a parallelogram, right? So if you can kind of visualize that this would be straight and this would be straight, we have basically a parallelogram. These are both length r, or the height would be length r, excuse me. Well, these would be length r too, but that's neither here nor there. The height in the middle here is radius, and the bases would both be 1/2 of the circumference. Now they're going to be 1/2 because the other half is on the other side, right? We only have half the wedges whose tops are up here, and the other half have their tops down here. So it's only 1/2 the circumference for each base. The area of a parallelogram is base times height. So if we take 1/2 times circumference and multiply it by the radius, 1/2 circumference times radius, but circumference is 2 pi r. So I have 1/2 times 2 pi r times radius. Well, 1/2 and 2 cancel. Now that leaves me with pi times r, or pi r squared. Now, obviously, this isn't a perfect proof because the fewer sectors you have, the more curved this is, and you have these like kind of lumpy curves going on. So this only works if you cut it into infinitely many sectors. That's what those little wedges are called. But you can see how it would eventually work. If you cut it into enough tiny strips, you would have a parallelogram. And that's the basis for where this proof comes from. A typical bag of cheese will cover approximately 400 square inches of pizza. How many bags are required if we have 5 18-inch diameter pizzas? Well, we got a pizza. It's 18 inches across. So the area is pi times the radius squared. Well, if the diameter is 18, that means the radius is 9. So this would be 81 pi. Normally, when we're talking about circles, that would be fine. But since we're trying to take this a couple steps further, we're going to need the decimal approximation. If you're typing this into a calculator, 3.14159 will be more than plenty. 3.14 is about as rough as you'd ever want to get. If you have a calculator, especially a scientific calculator, there's going to be a pi button on there somewhere. You just need to find it. So take a look at your calculator, look for the pi button, type in 81 pi. The area is going to be 254.47 inches squared. Now we have 18 pizzas. Multiply that by 18, and you end up with 4,580.4 square inches. If we divide that by 400, we will get 11.45. I don't know if you've ever tried to buy 0.45 bags of cheese at Albertsons, but it's probably not going to fly. So we're going to need 12 bags to cover 18 pizzas and cheese. An outdoor accessories company manufactures circular covers for outdoor umbrellas. If the cover is 18 inches longer than the umbrella on each side, find the area of the cover in square inches. So I know that the diameter is 72 inches, and that the cover is going to be 8 inches longer on each side. So here's a picture that can be really helpful. The umbrella is this inner circle. The cover is the outer circle. You'll see that it's 8 inches longer over here, which means it's also 8 inches longer over here. Area is pi times the radius squared. So all we need to do is find the radius, or the distance from here to here. Well, half of 72 is 36, plus the full 8 inches over here means that 36 plus 8 is going to be 44 inches squared. So if you leave it in terms of pi, you're going to have 1936 pi. If you multiply that out as a decimal, it will be 6,082.12 inches squared. This is going to be a yo-yo. I want you to find the radius of a circle that has an area of 95 square centimeters. Radius of a circle with an area of 95 square centimeters. So pause the video, take, I don't know, 90 seconds, and give it a shot. Okay, let's do this real quick. Always start with the formula. It's a great place to start. If I'm looking for the radius, the area is 95. So 95 is equal to pi r squared. So really what I'm doing is I'm looking to find r. So I'm going to divide both sides by pi and then take the square root. So the radius is going to be the square root of 95 over pi. Okay, so then you can see it the way the book did it. That kind of made that hard to see with my drawings here, but 5.5 is the square root of this 95 over pi. Okay, so sectors. A sector is a region of a circle which is bounded by a central angle and its intercepted major or minor arc. So let's see what that means. So these yellow slices here are what we call sectors. They are a central angle. So any angle whose vertex is at the center is a central angle. So these are all central angles. And it's bounded by two radii, right? We got two radii here. And then this is the arc intercepted by that angle. It's major if it is greater than 180 degrees, and it's minor if it's less than 180 degrees. If it's equal to 180 degrees, then it's a semicircle. Okay. So let's imagine that I told you the area of this entire circle was 24. How could we find the area of these sectors? So if the full circle is 24, how much would this yellow sector be? This one you might be able to do just by looking at it. Well, you'll say, well, that's a fourth of it. So a fourth of 24 is 6. Okay, now this one gets a little bit harder. You say, well, this is 30. Well, there's 3 30s in a 90, which means if there's 4 of those and 3 of those in each of those, there must be 12 30s, right? So a 12th of 24 is 2. So following that same logic, all we're really doing is finding what ratio of the circle does this sector represent. So 90 degrees is a fourth of the circle, 30 degrees is a 12th of the circle, and all we're doing there is taking 90 and putting it over 360. And when you reduce that, you get 1 over 4. 30 over 360 comes out to be 1 over 12. So we're just going to repeat the process, 110 over 360, and multiply that by the area, or 24. So 110 divided by 360 is going to come out, let's just do it together here. 110 over 360, I can divide them both by 10, that's 11 36ths. I don't see myself reducing that anymore, times 24. So 11 36ths times 24, I'm going to come up with 7.3 repeating for the area. We don't know the units, so we can leave it alone, but it'd be 7.3 square units. Okay, which means that the formula for the area of a sector is just the ratio of the circle that it takes up, or the percentage of the circle really that it takes up, multiplied by the area of the entire circle. So this is 53 degrees out of the total 360 times pi times the radius squared, or 16, because 4 squared is 16. So what I'm really doing is 53 divided by 360, and I'm just going to talk through what I'm typing into my calculator. 53 divided by 360, I would hit enter, times 16, enter, times pi. And then our area is going to be roughly 7.4. This one has feet, so feet squared. Area is always square units. And you just simplify this in a calculator however you want to, whatever's easiest for you. A jeweler makes a pair of earrings by cutting 2 55-degree sectors from one silver disc. Find the area of each sector. Let's start with that. So that's going to be 55 out of 360. We're just doing each sector, right? So I just want one of them. 55 over 360 times pi times the radius, which is 2 squared, right? This radius right here is our 2 centimeters. So I've got 55 divided by 360. I'm just going to hit enter after that, times 2 squared, which is 4, times pi. And every time I say that, I'm using the pi button on my calculator. If you're typing it in, you should do at least 3.14, if not 3.1416 or 159. But the more accurate you are with pi, the better. If you have the pi button, I would encourage you to use it. That means that my area is going to be 1.92 centimeters squared. B, if the weight of the silver disc is 2.3 grams, how many milligrams does the silver wedge for each earring weigh? Well, if the entire thing is 2.3, 55 over 360 is the slice of this disc that we're talking about, times 2.3. So I'm just going to do 55 divided by 360, 55 360ths times 2.3. Means that it will weigh 0.351 grams, because this was in grams. The question, though, was for milligrams. Well, there's going to be 1,000 milligrams in a gram, which making the answer about 319.4 milligrams. And if you're wondering why that doesn't match, I'm just remembering that I covered that because I changed the numbers on the practice problem to 55. It didn't used to be 55, so that's why that doesn't match up. So ours would be 351 milligrams. I had forgotten, that's why I'd covered that up, so that's my fault. Sorry for the confusion. That answer would be incorrect because I did change from 50 to 55 degrees. So a book's answer is wrong. It should be 351 milligrams. All right, finally, this one's on you. We're going to give you 2 minutes, so pause the video, tackle this one, and come on back. Find the area of this sector. The sector is the blue stuff. Find the area of the blue stuff. Okay, let's look at this together. I hope that you paused it and took a stab at this before we got going. I could find the area of this pretty easily. It would just be the 65 over 360. So instead, I want the measure of this angle. So 360 minus 65 gives me 295 degrees. And that's the angle I need to go with. So 295 over 360 times pi times 11 squared. Hopefully you would have come up with 311.5 inches squared. Okay, so again, feel free to, as always, rewind and look back at any formulas that you need. I hope you have a great day, and good luck with the homework. I'll talk to you later.